Previously, we had defined what a regular expression is. So remember that this is a nice declarative way of describing a regular language. I haven't got too many details about why it's a regular language, but most certainly I'm hoping that you'll cling on tightly as I keep using the word regular over and over again. It will eventually get to the point where we can actually talk about that much more intimately. So, I thought we would talk about designing regular expressions. Ooh, this marker's looking a little bit funny. You know what that means? Boo! It's gone. It's gone. Let's get a different marker. So we've seen a basic example before. We've seen actually how we can describe all of the binary strings. So I thought we would start off with something I would argue is not super easy, but something you maybe are not as familiar with. So suppose I want to have a regular expression that describes all binary strings. So those are those that consist of ones and zeros. So I want ones that alternate on ones and zeros. So 0 or more of these symbols. So 0 or more alternating ones and zeros. So just to give you some examples. So what this regular expression should describe are strings that include this. So 1, 0, 1, 0, right? They alternate on ones and zeros. So likewise, 0, 1, 0, 1, right? They're alternating. That's the point I'm getting at. So notice that these two strings, they have to be a part of the language that represents the regular language we would like to describe. So that's our goal, is we're going to try to come up with a regular expression that's able to, if I gave you this string, this regular expression describes this string. Likewise, some other ones. So like 0, 1, 0. Notice that in this case, it ends with a 0 and starts with a 0. Notice it's a little different than those two. So naturally, I would also like to include this one as well. So notice that all of these alternate on ones and zeros, right? Do you see that? So how about let's consider a few other strings. Would this string be a part of, like if I come up with this regular expression or language, its corresponding language, would this string be a part of that language? Is that a part of the language? So if I'm coming up with this, would 111 be one of them? How about this one? How about 110? Would these two be a part of the language? Are they alternating on 1 and 0? These ones wouldn't, right? Because they're not alternating. They're not alternating. See, these two would not. I don't want these ones to be described by the regular expression. Only those 4, for example, and many more. There's infinitely many of them. So notice that I can keep going on like this, right? I could go 1, 0, 1, 0, 1 like this, and so on. The point is I would like to design the regular expression such that it's just alternating ones and zeros. So any of these 5 that I have here should all be things I can describe with this regular expression. Namely, these are all strings in that language. But these last two, no, these aren't a part of that language. So I'm going to show you a couple different approaches for me to come up with a regular expression for the language in question. So the first approach, if you're dealing with a really tricky case, the first thing you might try doing is just exhausting this. Question. 1, 0, 1, 0, 1, 1. No, that wouldn't be a part of the language. So if I added a 1 here, it wouldn't be because it's not, it would be a 0 that would come after the 1. That's a good question. Excellent question. Yeah, so what we're going to just have it is so it just alternates on 1 or 0. So it's 1, 1, 0, 1, 0, 1, 0, or 0, 1, 0, 1, 0, 1, up to it's 0 or more symbols of that. Excellent question. So the first approach I was going to suggest is that we just try to exhaust breaking this into cases. So sometimes when people come up with regular expression, sometimes it's a little bit, it's a little tricky because it may have several cases. Do you notice that the 4 here that I gave you, notice that they actually can be broken into 4 cases. So each one of the cases actually is represented by one of these examples. So sometimes when you're coming up with these, you might think about, okay, what kind of strings, what's the form of the string? So when they get a little complicated, just break it into cases. And a natural idea here is that if I can describe the strings for one case and for another case and for another case, what can I do with each one of those? Well, if I design a regular expression for one case, and I design a regular expression for another case, and I design a regular expression for another case, so say 3 cases. In this case, we're going to have 4 of them, I believe. What can I do with that? There's something really neat about it. Well, I'll let you think about it. What we're going to do is we're going to exhaust all ways we can write alternating ones and zeros. So here's one possibility. So I'm going to start off with the easiest thing I can possibly try doing. Do you notice that in this first case, all it is 1, 0, 1, 0, and it keeps going, right? I can have 1, 0, 1, 0, 1, 0, right? Do you notice that every time I write down 1, 0 like this, and I write another 1, 0, then I write another 1, 0, notice that the string always starts with a 1, ends with a 0. So I'm going to consider this case first. So we're going to first consider the string 1, 0. So notice it's just the symbols 1 and then a 0. It's not 10, just to be very clear. So how can I describe this just as is? So suppose I wanted to have a language that is just going to be consisting of only one string. It's going to have 2 symbols. It's going to be 1, then a 0. So I think that maybe might be a good place for us to start. It's so that we can have it so it has 2 symbols in there together as one string in one language like this. So if we can do that, notice that if I just put a star on this, I can repeat this 0 or more times, right? Notice that if I had it where I pick it once, it's just 1, 0. If I pick it twice, I get 1, 0, 1, 0. If I pick it 3 times, I get 1, 0, 1, 0, 1, 0. So if I get that, we've covered what looks like this first one here. So let's try to figure out how we can cook this up. If I could cook this up, there's our first case. That would cover this one here. So I must stress that we're just doing all alternating strings like this. It doesn't have to just be only those 4. It could be any strings that have this form. These are just 4, think of it like test cases. So here we go. So how can we come up with a regular expression that corresponds to this? Let's think about it. So the first thing is that, how do I get first this in here? Well, I can take one, I can concatenate that language with this language, right? The one that consists of symbol 0, and then so I have these 2 languages. I concatenate them, and I take each one of the strings in here, concatenate it with each string in here. So if I wanted just this without the star, I might use a concatenation. So if I concatenate those 2, piece of cake, right? But what is that as a regular expression? So we can obtain this by concatenating the expressions. And what are those expressions? Notice that there's a regular expression for this, right? It's just one bold, but I underline it because it makes it a little easier for you to determine from the symbol 1 versus the expression 1, as we discussed previously. And this is that, right? So if I concatenate the two, the result of that should give me this without the star, right? By concatenating the expressions 1 and 0. So, i.e., if I represent this as a language, what I'm saying is take 1, concatenate the language that consists of this one string, which is one symbol, 1. I concatenate this with the language that only consists of one string, namely this string that's just a 0, that gives me 1, 0. So what this would look like as a regular expression, you might write this as 1 dot 0 like this. Or you'll find very often I'll just write it without the dot. Whenever it's unclear, I just simply will just write it without the dot because they're right beside each other. But if you were typing this into a system that was taking in a regular expression, it often will use concatenation maybe as a dot, whatever symbol it might be. It's a good idea to specify what the operator is. But for us, since we're doing this more abstractly, I won't write it all the time. Whenever it's unclear, I will, though. Okay, so now, so far we got that. So now all I have to do is one other thing. Need to get 0 or more occurrences of 1, 0, right? So what's the operator I should use? What's the operator? I'm going to use a star operator. So now, I need to do it to all of the expression, right? So this would represent this right here. So you might ask, Dan, what is this? What's the language of this? This consists of all binary strings that consist of nothing, right? You can take nothing out of this, right? You can take, so you have nothing. You pick it once. You pick it twice like this. You pick it 3 times, and so on. That's what this regular expression actually represents. So that's actually the language of this regular expression. Yes, exactly. So this is the first case I was thinking about. Now, you can think about this in many other ways, but this is the first case I was thinking might be ideal. Because notice that the way the string begins and ends can actually change from just this first one, as I mentioned. Notice that this first one here, so this would account, for example, see, notice it's right here, right? So far I got that one accounted for at least. Think of these like our test cases. So notice that this one starts with a 1, ends with a 0. So maybe it might be natural to consider when it begins with a 0 and ends with a 1. Then there might be another case for when it starts with a 0, ends with a 0, and then maybe where it has a 1 and ends with a 1. So you'll notice that the first case is going to be very similar to my second case. So let's consider, so to get all strings, that start with 0 and end with 1, I was going to suggest that we simply reverse the way the concatenation occurs, right? Right? That's all we need to do. So to note that, remember, if I want 1, 0, 1, 0, 1, 0, if I want 0, 1, 0, 1, 0, 1, what I'm suggesting is we just swap these two around. So just take 0 and 1, make it 0 first, then 1, instead of it being 1, then 0. i.e., we will have 0, 1, star, where the 0 and 1 are together upon a concatenation there. So this is the expression for the symbol 0. This is the expression for the symbol 1. I group them together with parentheses, and I apply the star operator. So notice now this will definitely include strings such as this one. But now we have 2 more cases. Exactly. Very good, very good. So let's head over here. Let's take on the 2 remaining cases, because this definitely won't cover all of them. Because somebody could potentially, just as a quick example, somebody might want to just give you a 1, or they might want to just give you a 0, for example. Or it could be the case like we have these 2 strings here. So I need to make sure I account for those. If we don't account for them, oh boy, I'm missing some. So here we go. So naturally, the next case is when we start with a 0, end with a 0. So please think about how we might use some of the ideas we have so far. So remember that up to this point, we've seen how we can start the string with a 1 and end with a 0. And we've also seen how we could start the string with a 0 and end with a 1. So all we need to do now is incorporate both of these corresponding ideas we had over here with the idea that we start with a 0 or start with a 1, right? In each of those respective cases. So notice that they're going to be very similar to what we had before. Yeah, you're right on the money about what I'm thinking about. And there's many ways that we can actually represent this. I'll show you a different way of going about it. So check this out. So to obtain all strings that start with 0 and end with 0, so I'm just going to simply adopt the first idea we had. Do you notice that in the first idea that we had, we started with a 1, then we ended with a 0, right? So all I'm going to do is I'm just going to concatenate whatever the result that was. I'm going to put a 0 on the front. So I'm going to take 0 and I'm going to concatenate it with whatever I did in the first case. So check this out. So take our first idea. Let's take our first idea, but concatenate the expression 0 on the front. So if we do this, we end up with the expression. It's very similar to the one that you have. But you could just simply take the same idea and you just play around with it, right? So check this out. So I just have, so remember, in the first case, I have it where it'll start off immediately with a 1, but it ends with a 0. So I'm going to have 0. I'm going to concatenate this with what I had in the first case. So notice that it begins with a 0, but then I'm allowed to write 1, 0, 0 or more times, right? I could be 0, then I could go 0, 1, 0, 0, 1, 0, 1, 0, and so on. Man, when we get to the easier way of approaching this, you're going to feel so silly about it. I know when I first see it, I'm like, dang. But the main motivation behind what we're doing here is that if you deal with a more sophisticated regular expression, this technique might be more versatile than sitting and banging your head against the wall for like a good hour or 2. Right, Miss Kitty? Yeah, Miss Kitty agrees. Sometimes exhausting cases, then simplifying later might be a good strategy to start off with. So naturally, we could do the same thing, but now we just got to do it with this second case. So to obtain, so similar to the previous case, so all strings that start with 1 and end with 1 and end with 1, well, all we have to do is just, okay, so remember, we want to have it where it is, what do we want? We want it to be a 1, then a 0, then a 1, then a 0, but we need to make sure we always count for just at least 1. But yeah, most certainly. But like I said, you can get actually both of them. But yeah, so I will get to the point of why, but when the empty string appears in one of these languages, as long as we account for it in one of them, we're okay. That's actually a really lovely question about the empty string. I'll get to that actually in one moment. So let's talk about that in one moment. So remember, I'm just going to use the same idea. So similar to before, all I'm going to do is have a 1. So I want to make sure it starts with a 1, but it ends with a 1. Notice in our second case, I can allow it so it goes 0, 1, 0, 1, 0 many more times, like this. But remember, each one of these is a set of strings. But now I have 4 possibilities. The strings that we have fit into one of these 4 buckets. And you might ask, Dan, how do you know this? How do you know that it fits exactly into these 4 buckets? And it doesn't have to be that they're disjoint, just to be very clear, because some of the strings actually sit in multiple buckets. My point is, how do you know that you've covered all of them? Well, remember, every binary string begins with a 1, ends with a 1. It may begin with a 0, end with a 1. It could be beginning with a 0, ending with a 1, and so on. But there's only 4 of them, right? There's only 4 ways that could happen. So as long as I count for all 4 of those, via cases, I've counted for all possibilities. So let's talk about this disjoint business. So I must stress that technically speaking, they don't have to be disjoint. Because what we're going to do now, so this is the cherry on top of this. So notice that all the above here, so I'm not going to formally prove that these are all 4 possibilities that can happen. So what we're going to do is we just use union on all 4 cases. Thus, we end up with as follows. So to answer your question, if it mattered that, okay, this string is represented by this expression, but it must not belong to this other one, then the disjointness of their corresponding languages would matter. In this case, it doesn't matter that if 2 of the cases actually consist and contain the empty language. Not the empty language, the empty string. Don't mix those 2 up. It's okay if, say, epsilon appears in a couple of these. It's okay because we're just going to perform a union operation anyways. So what I was going to suggest is break it into cases. So here's our first case. There's the first case. There's our second case. I'm going to perform unions with all of these. So I made a much more complicated looking regular expression out of the 4 cases. So notice here that I have the 4 cases, but by using union, I've captured each one of them. So notice that if there exists a string that's in one of these, say for example, these 2 cases actually both contain the empty string. So in these cases, it doesn't matter because it's in here, but if I perform a union between the language of this one and the language of that one, they're both actually, it doesn't matter, it just appears again. And as far as we're concerned, it's just the set of strings in that language, the empty strings in there. It's in there, that's all that matters. Does that clarify the issue around like, okay, Does it have to be disjoint or does it not to be disjoint? It doesn't matter. It actually doesn't matter in this case. As long as we account for it, that's what matters. But if we were, for example, instead of us trying to have it where, right, and keep in mind, our examples would be quite dramatically different than this one. The point here is I broke it into cases, and each case, they don't necessarily have to be disjoint in this case. They can overlap. As long as I account for them, though, that's what matters here, because the union operation would disregard the fact that duplicate strings exist in the first place. Yeah, so, but if it was, for example, that I wanted the first case to happen first, then the second one, then the third, then the fourth, and I didn't want to have it to have empty strings in a certain way, maybe I might consider it a little bit more carefully, but and that's not the language we're looking at here. Now, you might look at this and say, Dan, that looks awfully complicated. But it most certainly would work. If it's unclear, you can always add more parentheses. So if you want this union operation to occur first, second, third, you can add parentheses. But in this case, it won't matter. That's just clarity on our parts. Because you just read it. You can read it, for example, left to right. But let me show you another way of thinking about this same language. And when I first seen this, I'm like, why didn't we just do this from the get-go? And the minute you see this, you might say, oh, Dan, why didn't we just do that from the get-go? And that's exactly where I'm going with this. It's because I want to show you that you can go about this in a much more complicated way if you need a more complicated regular expression. One common place where this pops up is if somebody asks you to detect a string that isn't a part of some other substring. Cases where you break it down like this might be worthwhile, because designing one just for like a very tailored one may take a very long time to do, but it might be worth it, but you have to start somewhere. That's the point I'm getting at. So let me show you a second approach with the same example. So we've seen that, okay, we can write out zeros and ones, and we can use a star operator, but you'll notice I didn't actually use the versatility of the regular expressions really a whole lot. There's actually a very, very lovely tool that we actually did not use at all when we came up with that regular expression. Do you recall that we actually have another regular expression, right? We have the regular expression for the set that consists only of the empty string, right? So this is also a regular expression. So we can actually use this to help us design a regular expression that's much simpler in terms of the length of its description. So here's another approach. And I want to show you this because it helps really open up the doors for how you can use epsilon in a regular expression. So check this out. Do you remember we had 4 cases, right? We had the 4 cases. It starts, remember we have it where it starts with a 1, ends with a 0. We also had it where it starts with a 0, ends with a 1. We also had it where it starts with a 0, ends with a 0. And we also had it where it starts with a 1, ends with a 1, right? Those were our 4 cases we had previously. Would it be nice if I could have it so that I have some way of optionally fitting these 4 possibilities in the appropriate spots? So that's where we're going to go with this. So check this out. Check this out. Is we can use epsilon to include an option. To include an option. So we can obtain a shorter expression. So let me carefully think about this with you. So check this out. Check this out. So we know how to come up with one where it goes like 0 and then 1, 0 more times, right? We know how to do this. This is one of the cases we actually had. And the reason why I brought this up when you were giving ideas for coming up with the regular expression, I thought you were heading in really a good direction, is Because if you think about it, if I were to put a 1 right here, you would get 1, 0, 1, sorry, you have 1, 0, 1, 0, 1, 0, 1, right? You can keep repeating zeros and ones. But and the reason why I specifically picked it like this is, what if I can allow it so because remember, this will end with a 1. If I can allow it to include a 0 optionally at the end, that'd be great too, right? So check this out. So for this one right here, we'll cover this guy, right? That covers that second case we had. Because that's the one we had from I believe the second case. If not, either way, it's one of the main cases we had. So what I'm going to do is check this out. So this is how I'm going to use epsilon. So watch this. So I'm going to allow me to pick between epsilon or the expression for 1. So you might ask that, you might be staring at that and be like, okay, so what the heck is that? What the heck is that? So let's think about this in terms of languages. So what the expression for epsilon is, remember we talked about it is just simply this set. It is just the set that contains the empty string. If we take that and we perform a union operation with this set, which that is the expression for 1, notice that this gives us just this language, right? The one with epsilon and just the string with just 1 in it, right? So notice that now if I have this gives me actually additional versatility, because when I want to concatenate that with the resulting of whatever this does, right? Then what happens is now I can pair it with epsilon or I can pair it with 1. So if you think about it now, this gives us an optional 1. So I like to think of the union operation like an OR. I like to think of it like OR because that's quite natural to think about union. At least from a logical standpoint, you like to think of union like OR. So this gives you an optional 1. And then what should go right here then? So notice that if I have that there, this will actually cover my butt here for this optional 1. So now I can start the string off with a 1 if I wanted to. But also, I would like to have it so that that I can get these two. What would you suggest I could put right here? Yes, that's what I'm suggesting. Is that we put right here, that's wonderful. That's actually really great. That's really great. As I suggest that we do this, is we concatenate after this, we take and put this here, giving us an optional 0. So now notice that I can pick epsilon, then that means I can start the string off with a 0, and I can end it with a 0 if I wanted to. Likewise, if I take the optional 1, I do something here, and I take the 0 as opposed to epsilon here, I can end with a 0 here. So notice how this epsilon actually gives us an option now. Pretty nifty, right? Because it's all about how concatenation works. If I give you an empty string, you concatenate it with something, it's nothing, right? It gives you an option in this context. So it's just like, hey, look, you got nothing with everything that comes after it. So in the context of regular expression, we can use epsilon here like an option. So notice that this is much more concise than that one, but maybe not so much more, but it gives you some versatility. That's one thing I didn't really show you, is how you can use epsilon. So epsilon here actually gives us an option. So that's how very often you can use it in combination with union like this. So if you want to give an option for what symbol you might pick next, epsilon is your friend. Is that clear? So just remember, wherever necessary, include parentheses. So remember, the way you group these, oh yeah, I forgot to underline these two, very important. Those are technically our expressions that have concatenated. But yeah, so there's another approach. So notice here that I'm using epsilon to allow me to optionally select a 0 or a 1 in the appropriate spots. Sorry, I'm getting really excited here. So I'm just going to note here, just please remember about the parentheses. Because it's so easy to just be like, oh, I could just read it left to right, and then forget about that there's a precedence for the operators. So remember, star, concatenate, then union. That's the order from highest to lowest. Parentheses are your game changer that always is above that. It specifies ordering. Just like when we talk about an algebra, right? So whenever it's unclear, just use parentheses. So I thought it would be fun for us to do some more examples, because this one, we've been playing around with this. We got a little bit slower. I thought it would be fun that we do, I think, at least a couple more examples. And then we see some, I would argue, more kind of applications-driven examples. Just so you could see, like, oh, I could use this to, I can, like, design a regular expression that does this sort of thing. And there are a couple of them are pretty neat examples that parallel something we've seen actually last week. So let me head over here. But are there any questions? Any questions about this example? I think we got a pretty good grasp on this one. But yeah, epsilon is your best friend. It gives you some optional, gives us some options. It's all about how that union operates. Okay. So let's do some more examples of designing regular expressions. So what I thought it would be wise for us to do, because we've seen, like, I would argue it was kind of cute, kind of basic, but at the same time it's fundamental. I think seeing how you can write out binary strings in a particular form is very important. But let's try to do something where I give you the language and let's try to come up with a regular expression for it. So let's try this out. So let's do some more examples. But now what I'm going to do is I'm going to give you the language. So we're going to consider strings. So we're going to consider all the binary strings. This is how I would describe that using regular operators. Such that, so this means such that W contains only one. So what we need to do is we have to come up with a regular expression such that if I give you a binary string, it has to describe only binary strings that only contain one. So for example, if I give you like a string that looks like this, that's okay. It only has one in it. One, right? Of course, it only has one in it. 0, 1 has only one in it. However, if it has 2 1s in it, not okay. Not okay. So let's think about what we could do here. So let's try to put into practice some of the things that we've seen so far. So far we've seen that we can use concatenation to bring together pieces that would make the form of a string. So I really want us to kind of take a big step back before we try to really put down ones and zeros. Let's think about what the string would look like if it were to get accepted, if we were to imagine this like a DFA. See, I caught myself there. So imagine I give you a string and I want to say, hey, look, I want to have it where it only has 1 1 in it, but it's not allowed to have 2 or more or 0 1s in it. So what would the form of it look like? Well, it would look something like this. So the form of it, so this is something you might get used to doing if you're thinking about regular expressions. is, okay, it has to contain 1, 1. So you know the string looks like this. It's got a 1 in it. And there's other stuff. But what's the other stuff? What would be right here? And what could be right here? What could be over here? Well, there might be stuff, right? But notice it's not a 1, right? So we've got 0. I'm going to use words here because it gets a little confusing when you talk about zeros and then you talk about the literal symbol 0 versus a value 0. So we have 0 or more zeros here after the 1. And we have 0 or more zeros before the 1. So if we can identify the form that looks like this, notice that every one of the strings that would be in here has to have this form. Yeah. So notice that, yeah, exactly. So notice that it can have zeros, or it could potentially be the empty string. Do you see that? So here it could be 0, 0, 0. It could be a whole bunch of zeros. It could be as many zeros as you want. But it also could be no zeros, correct? Just like we had in our one example over there, we just have a 1 just sitting there. So you might be compelled to use epsilon here. You might be compelled to use it in some way. You could, but you don't actually need to. Because let's think about this. If I have 0 or more zeros, well, what would that look like? It would be, you would have epsilon, you would have 0, you would have 0, 0, 0, 0, 0, 0, 0, 0, 0, right? So if I wanted this language, the language that consists of all of these, if I keep repeatedly doing this, what would that look like? So what language actually is this if I were to describe it in terms of regular operators? Well, let's think about it. Well, it would be 0 star like this, right? Well, that's at least what the language would look like, right? Because if I don't take this, it would just be the empty string, right? Then I could take 0 once, 0 twice, 0 3 times, 0 4 times, and so on. Well, let's think about what the regular expression for this is. Well, let's think about it. It's just, this one's really nice and easy. It's like our previous example, except it's even easier because it's just one symbol. Well, it would just be, let's see, we got, this is for the set that consists of only the symbol 0, right? But I want as many of them as I can, or none. So I apply the star like that. So notice that this is the key ingredient for what I've put right here and what I put after the 1. So what should the regular expression look like then? So what should it look like? So the resulting regular expression would look something like this, right? So this is the form that we would like, because that's what corresponds to this. So our regular expression will look like this. So we know there's going to be a 1. We need a regular expression for 1. And then before and after we're going to concatenate something. What should be right there? We're just right on the cusp of it. So we got what comes before and after. Well, we know we need 0 or more zeros. And we need 0 or more zeros after the 1. And boom, that's it. That's the regular expression. So notice here that I've taken advantage of the star operator to mean take none. So like in our previous example, we had it where we use epsilon to make an option. We don't need to use that in all these cases. Sometimes star is enough if you just don't need any of one. But notice that star is helpful for us if we need multiplicities of that symbol or groups of symbols. So Are there any questions about this example? So I thought this was a pretty cute one. I thought we would do another one that involves the length of the string next, because it's nice to see different properties about strings. So here we're counting. So notice that here, if I wanted to actually change this, so while you're thinking about anything interesting, notice that if I were to change this ever so slightly, so W contained 2 ones. Do you notice that you could just apply the same idea again? But notice that if I need 2 ones, notice I can have 0 or more zeros here, 1, 0 more zeros, 1, and then another 0 or more zeros, right? Do you see how you can keep applying this principle if I wanted to count certain finite numbers of occurrences like that? So you can see how you could generalize this a little further if you needed to. Pretty nifty. So I don't see any questions, so why don't we proceed to our next example? So I thought I would show us something about the length of the string, because it's helpful to sometimes think about different properties the string might have. A nice basic one is if the string's length is appropriate. So a nice one, mirroring some of the examples we've seen in the past about regular languages, would be asking a question about the length of the string. So let's consider this following language. Suppose I want to have, over the set of binary strings, I want to consider the following. Let's consider when the length of the string, so I'm going to denote that with these vertical bars. So the length of the string is equal to 2k for some integer k that is greater than or equal to 0. So please note that we would want to think about this very carefully, because notice it's k is greater or equal to 0. So that means that we can include several different kinds of strings as long as they have even length. So just as an example, since k can be 0, that means that the length of the string can be 0. There's only one possible string for that, namely the empty string, right? But we could also include other strings in this language. Well, it's corresponding, well, this language specifically. I was getting a little ahead of myself. I got 0, 1. So notice that this has even length because k is equal to 1 in this case. I can have it where I have a binary string like that. That has length 4. That's when k is equal to 2, and so on. But notice that it could be any binary string that has even length. So that includes the empty string because that's the string that has length 0, right? There's only one such string. So let's think about this carefully. So previously we had seen how we can effectively get options, right? We talked about how you can have it, oh, I want to pick a 0 or a 1. And we talked about this previously, right? So we said, okay, I want to have it where I can pick 0 or 1. So this would be the language that consists of only 0, 1, but I would like it to be so I could keep picking 0 or 1, akin to what I have here. So let's think about that first, before we get thinking about the star business, because we have to talk about the length of the string. Very important aspect that we have to figure out how that works. But we know how to do this as a regular expression. So this would be the language of the following expression. Right? So, yes, see, you're really right on the ball. I like this. That's where we're going. That's what we're going for. So notice that if I have this, that gives me my choice of 0 or 1. But as suggested in the chat, if I want to force it to have an even length, I want to combine this with an idea we've seen previously. So I want to be able to pick 2. So I want to pick 2 symbols. I want to do this 0 or more times. If I can do this, then I can recognize this language, right? I can describe it. I can describe this language. And there was a lovely suggestion in the chat for how we can do this. So let's tackle the pick two symbols part. So this picks one symbol. That picks two symbols. And we said to do it 0 or more times, right? And we've seen how star can be used to do that. And that's a lovely regular expression for this case. See, really catching on here, and I really like this. Wonderful. So let's see what else I got here. Let's do another one. So seems like we're really catching on here really well. But yeah, so naturally I can use concatenation. So I have an option, then another option, but I'm forcing there to be an option. If I want to include the ability to pick, say, the first one as an option, I might include an epsilon, but that's definitely not this language up here. So let's do another example. Seeing as now I've shown you one with the length, how about let's consider one with a substring. I think that's a pretty good idea. We see one with a target substring. So suppose that we give binary string again. I must stress that I'm just using binary strings to keep this nice and simple, but it's fairly easy to generalize many of the principles that we're seeing here. So say, for example, you're working with ASCII characters. It's just that now you just have more symbols you're working with. Or even alphabetical letters. So suppose let's consider the binary string such that W contains substring 0, 1, 0. So the reason why I wanted to show you this example is actually it's because it's more like an extension of one of the previous examples we did. So do you remember how we tried to come up with a form for the regular expression? So just as a quick example, just to show you what kind of strings would be fine here. Obviously, one that just has this in it, that's okay, right? If I had 0, 0, 1, 0, 0, this is okay because it's right there. However, a string like this, just with 1, 0, not okay. So let's think about it. Previously, we had seen how we can come up with a regular expression for... No, wonderful, wonderful. See, that's the whole point of this, is I'm trying to get to really cozy with this idea, just thinking about how you can formulate these. So let's think about this. Okay, remember how we had the example where we wanted to catch exactly 1, 1, right? So do you notice that it's very similar to actually this question if you think about the symbol, that 1, as this substring. So let's actually now revisit the same strategy we had before. So the form that we had, so let's think about a form for the string. So the form, we know for sure it has to have this in it. It has to have that in it. Yes, yes, exactly, exactly. So notice that now, what do you want there and what do you want here? Because notice it has to be somewhere in it. It contains it. It could be at the beginning, it could be at the end, it could be somewhere in the middle, right? So let's think about it. So here is going to be some binary string, right? So something before there's going to be a binary string with 0 or more symbols. There's going to be another binary string with 0 or more symbols, right? So now that we've seen how to do it with the contains exactly 1, 1, you can see quite quickly how we might try to do it here, right? Because it's just the same, it's the same concept, except now it's not just everything but the 1, right? It's just, so let's see what we would do here. So let's try to use the same idea we had before. So remember we have our target, so this is what we were trying to look for. So any string must have this in it. We know that. But now we have to have a binary string with 0 or more symbols, right? We already seen how we can pick a symbol. We can pick a symbol, but I want to be able to pick 0 or more symbols. Then I do the same thing here, right? I was getting a little excited. My plus was starting to melt into something else. It looked like melted cheese or something. And there we go. Notice it's just the same idea, except now all we have, yeah, exactly. Exactly, very good, very good. So notice that it's just the same principle, but now instead of it just being a bunch of zeros, it's just a binary string. Lovely, lovely, lovely stuff. So hopefully you found these examples rather helpful. I thought we would be a good idea we see some trickier examples next. But these are going to be examples related closely to actually some things I've shown you before, but they also will help motivate some other ways you can use the regular expressions. So let's head over here to see a couple more examples. So we're going to apply the principles that we've seen up to this point, and we're going to try to see what we can do some interesting things. So these are going to be similar to examples I've shown in the past, and they're done deliberately to be similar to ones I've shown you when I was talking about finite or finite automatons. So I thought I would show you a couple more examples. Now, these are also help motivate a couple of the applications that you might run into out in the wild for regular expressions. Naturally, say in the case of searching bodies of text for certain key phrases. Likewise, also for design or certain analyses of strings. So, for example, you may have heard of something called a lexer. Generally, a lot of this regular expression business has numerous applications in text search, and along with compiler design. Like, it's all over the place. It's a helpful thing to be aware of. That's what I'm getting at. So I thought I would show a couple more examples. Now, the main reason I want to show these examples for you is because we've actually designed epsilon NFAs for these. So these are non-deterministic finite automata with epsilon transitions. So I want to convince you that we can come up with regular expressions for those finite automata. So instead of me talking about just a machine, I could describe to you the regular expression for which describes the same language that machine would recognize. And you'll see that there's actually something interesting going on. So we're going to revisit a couple of ideas here. So first, we're going to talk about recognizing key phrases or keywords. So I want to remind you of the scenario. So don't worry if you haven't seen these before, don't worry. I'm just going to rehash everything. So suppose that you are typing on a keyboard and you have some key phrase that you're looking for that is the most recently typed part of the string. So imagine you're keeping track, say you're logging the inputs from the keyboard and they're being typed into a box. And I would like to know if the most recently typed sequence contains the key word. So this would be at the end of the string. So let's design, but these looking a little bit concerned. Let's design a regular expression. I'll just abbreviate as regex. Regular expression where strings end with the word Pam or no. Don't ask me why those are the words, but those are just the words. The principle should easily be extendable to other cases, but it has to end with Pam or no. So we know how to get that kind of option first. So let's think about the form of it again. So you would have any of A, B, C, all the way up to Z, 0 or more times. So there could be stuff here before that, but you know that it's going to be Pam or no right here, right? Has to appear. That's kind of the form of this. So let's try to put this into some plain, put it into our regular expression. Yes, that's exactly what I was looking for. Bang on, bang on. So what would the resulting regular expression look like? Well, let's just put it into the form. Perfect. Perfectly done. So I have regular expressions for each one of the symbols, and then I group them all together with union operations, put it all together. And then I just naturally put a star on this because I want to be able to do this 0 or more times. So I pick one of these symbols 0 or more times. And then naturally, I concatenate this. Whoops, I don't want to underline all of them because they're all technically different symbols. I have Pam or no. But it's right at the end. And that's the regular expression. Yeah, you bang on 100%. Awesome stuff. So notice here, this will detect it at the end. If you wanted to have it so it just contains Pam or no, you would just take this and just throw this also at the end too. So you just concatenate that onto the end. One thing I should mention as sort of a convention as well, and some actually in some libraries it works sort of like this as well, is that if ever you need to like just access the whole all of these symbols, you could just simply, instead of writing all of this, some people would write just this. You would just have sigma star like this, which is quite natural. Then you would just have Pam, union, no, like that. Some people might write it like this. They might emphasize this with the dot for the concatenation, but anyways, that's another way of writing the same thing. Some people would write it like that. I prefer trying to exhaust it all out for you, but most certainly this is just another way of writing the same thing because you already know sigma star is 0 or more symbols from that set, right? So anyways, that's one example. Just detected keywords, rather nice thing to think about. How about reading decimals? So imagine I give you a bunch of digits that are supposed to be for a number. Now we've seen this rather, I don't know, it's a classic example. It's actually from a book by Hopcroft et al. It's a classic. For reading decimals. So we're going to come up with a regular expression that could recognize like it has the form of a decimal string. So this one's going to be a little bit trickier, but I'm going to show you using regular expressions that we can actually express it quite simply with the use of variables. First, I'm actually going to, instead of looking at this like I'm just going to try to come up with one right at the beginning, now that I've laid it out like this for you, I want to really emphasize that, okay, I have this is an option, but I do one of these. So naturally, I've actually broken down really 3 steps for you. The first one is an optional one, then you pick one of these 2. Right? So if I could come up with a regular expression for this, and then I come up with a regular expression for this, and a regular expression for this, as long as I can compose together the form as per the instructions, I can come up with a regular expression for all of it. So that's what I'm going to do. So sometimes if it's really complicated like this, I would argue this isn't terribly complicated, but it's a good example of how you might try to take regular expressions and combine them with other regular expressions. So let's start off with, first let's look at 1. So let's look at 1 first. So suppose I want to come up with a regular expression that will just simply allow me to have it where you put a plus, a minus, or nothing. So you can think of this like if I had positive 2.0, I would like to have it so I can put a plus here or a minus or just nothing. So it could just be 2.0. But I would like to only consider just this first part. So I would like to have it where it's optional plus or minus. So the form of this would just simply be plus or minus or nothing, right? So what would that look like as a regular expression? So I'm going to actually give it a name. So remember, we had a technique for how we can include an optional symbol. So I'm going to give it a name. I'm going to call it E. So what would this expression look like? Now, it's really hard to type it in, so I think it'll be a good idea I kind of walk you through it. I know that probably somebody's just staring at this for like, Dan, I already know how to do this, right? Well, suppose I have a symbol for the plus, This is going to get a little confusing because we have plus for union, but it's going to be the plus sign as a regular expression, union, the minus sign or negative sign as a symbol with its as its expression, right? So this is the expression of the minus sign, or I have the option to not include either of them. So that's one, right? So that seems pretty darn nice. So far I have that. Like I said, it gets a little confusing. That's why I'm using these underlines to help us emphasize which things are the expressions, which things are the operators, with the exception of epsilon and the empty language. So let's look at 2 next. So let's look at 2 next. So I'm going to call this F. So let's put all the stuff we know together to try to figure out this one. So it says 0 or more digits. So remember the digits are for us are 0, 1, 2, all the way up to 9. So those are our available symbols. Then we also have a dot. So dot is something we also have access to as a symbol. So let's think about how we'd put this all together then. So it says 0 or more digits. So the minute you see 0 or more, that tells you probably star is going to be your best friend here, right? So I'm going to have 0, 1, 2, but I'm going to put unions between all of these with a star, right? That's the first thing that kind of sticks out at you as like a sore thumb. 0 or more digits and a dot is coming after this. But note, just to be very clear, I'm going to underline it to make sure it's very clear that that's a symbol and its expressions, because this dot is not concatenation, right? It's a decimal. This is why I underline them or boldface them in my notes. It gets very confusing otherwise. Now we need to have a string of digits, but we need at least 1 digit. So one way we could do this is come back to one of our previous examples where we needed to have at least 1 symbol of a particular form. So I'm just going to include a mandatory choice of one of the digits. Then I'm just going to use star on here on this last choice. So this right here will force there to be at least 1 digit, and then I can have 0 more after that. I think that's pretty nice, right? One remark I will make is that if ever you want to say 1 or more, some libraries will support this, but there's also a formal way of writing this. Instead of writing star, you would use plus as the exponent. So some would refer to it as plus. That is 1 or more. So the equivalent way of writing this last part would just simply be where you would not have this right here, and you would have a plus right here. But I'm just going to keep it simple, just talk about star. But some libraries actually do support that functionality. Okay, so that's that one. Now that we have all the bits and pieces for the second case, let's just put them into practice. I'm just getting so excited the words are just slipping out of my mouth. Let's get the third one here. So this one is very similar to the previous one. So it says a string of digits, at least 1 digit. So we're just going to use the same idea we had here. Just put that right there. With a star. Then we're going to have our regular expression for the dot symbol. And then we're going to have our 0 or more symbols that come after it. Boom. There we go. There we go. Now, I believe I've got that carefully. Let's see. We got our at least 1 digit on the side before the decimal. Then we have 0 or more after that. There we go. So the reason why I wanted to show you this example, other than the parallel with the epsilon NFAs that we've seen previously, is that I want to show you that if you have multiple steps like this, design the regular expressions for the smaller steps, and then you can use regular operators in the form of the regular expressions corresponding representations of those operators to express the more complicated one. So let's take a look at what this would look like. So it says optional plus or minus sign. So that's E. So our regular expression would look something like this. You know it's going to start with E. Then what comes after this? We have 2 or 3. So you got a choice of 2 or 3 that comes after. Which one, what are we going to do? So remember, I have these represented as variables now. So I can use these names as opposed to writing out all those big complicated things over there. Well, if I want to choose 2 or 3, notice that that's the same as me having F plus G, right? So putting this all together now, I have 1 that happens, then I pick 2 or 3. So I concatenate this with F plus G. And boom, there you go. So you can design the regular expressions or come up with these regular expressions for more complicated cases and use the regular operators to bring them together into a particular form akin to this example. One thing I will point out is that this is very interesting in several regards, because the epsilon NFAs for the first example and the second example, they have very similar kind of structure to them. Namely, the epsilon NFA that we had in our first example had it where we had these pathways that would have the key phrases, but it would have it so we can keep producing more guesses. This is it should remind you of something that looks kind of like that we had over there. And over here we had 2 pathways that would split off. And that was only because of how similar these 2 cases here are. So we kind of especially designed it to handle these 2 cases, but it's almost like I had the choice of one or the other.